And we are live. Live from Studio F106 in Casa Grande High School. I'm just kidding. That would sound good, huh? Alright, so today's objective. Last year we did a section where we were working with functions on this thing called direct variation. You guys remember? Y equals kx or xk, where it was direct variation. It'll come back to you in a second. What we're going to be doing today is starting chapter 8. And in chapter 8, we're going to be working with rational functions. So it's like we're taking the lines and we're flipping them kind of thing. So what we're going to be working is with ratios, aka fractions. So that way there's no surprise. This entire unit is about the F word, fraction. Alright? So the objective today is talk about this thing called inverse variation. Inverse variation. We've done direct. Now we're going to do the inverse. What you need to know today, go ahead. This is section 8.1, inverse variation. So here's what this objective for today is saying. Let's say you have two data sets. And if x is increasing, and y is decreasing, so if one goes up and the other one goes down, and there's a constant relationship between those x, y's, then you have this thing called inverse variation. Okay? So trying to make that a little bit simple for you, we're talking about inverse variation. I'm going to write that up there. Inverse variation. Okay? And here's what you need to know. If one is going up while the other one's going down, they're doing the opposite thing, right? If x is going up or y is going down, that is the opposite of the behavior of the other, correct? So that is inverse behavior, aka inverse variation. Okay? So that's the objective today. Now there's a couple examples here we're going to talk about. They should be in your guys' student companions. I don't know if you can see them very well, but I'm going to throw up this first one nice and big. It says y equals k xy. So we have z, x, and y. K is our constant k. We're always trying to find that guy, right? So we can see what the relationship is. But here's what you need to know of this equation, is that z varies directly with x and with y. It varies directly to x and y. And if we had z, x, and y, we could plug them in, find k, and then we can make a whole new equation. Remember that? If you didn't, go back and look at the video. Go find it somewhere on YouTube. So, you guys okay with me? Z varies directly with x and y. Yes? Questions on that? No? None? Can I get rid of that? This writing.
Wait, z varies directly with x and y?
Yeah, jointly. This is in your companions. There's no need for you to write all this down. Let me put up the next example. This says z equals k xy over w. So we introduced a variable. Z still varies directly or jointly to xy, but it varies inversely with w. It varies inversely with w. Looking at the last one, they take this w, they throw it down here. In this example, z varies jointly or directly to x, but inversely with w and with y. Make sense? So, big piece of advice I can give to you, whenever you hear it varies directly or jointly, you throw that variable up top. And if it varies inversely, then you throw that variable in the denominator. Okay? Question. When do you throw k in the denominator? When do you throw k in the denominator? No, you don't. Never do it. Never do it. Always throw it on top. Because that's what you're going to find anyway. Hey, if any portion of it finds itself down there, then cool, but you always throw it in the numerator, okay? Questions there? Oh, she got some tahini back there. Nice. Sorry. Enjoy.
You want to?
I don't. I can't have Cheetah with coffee. It's kind of weird.
Oh, yeah.
I've had Cheetah with chocolate. Have you had chocolate chili?
No.
that's good stuff. Go to Fine Foods, AJ's Fine Foods, and they have chili infused chocolate.
Oh, it sounds good.
It is good. It's kind of weird, like the first couple bites, but if you palate it, like not chew it, wow, delicioso. All right, cool. Questions here?
People are watching YouTube videos. God, this guy is the weirdest thing.
You know, it doesn't bother me. Think what you want to think. All right, so let's identify these, okay? We're going to identify direct and inverse variation. And I think we kind of did already, right? If x goes up and y goes up, then possibly we have a direct variation. If x goes up and y goes up, there's a possible direct variation, a joint variation. If x goes up and y goes down, then that would be a key, right? That'll say, hey, we got a possible inverse variation. And notice I keep throwing possible in there, right? Because just because one does the same thing as the other doesn't mean that there is a relationship, or if one goes up, the other one goes down, doesn't guarantee that there's a relationship there either. Okay? There's one more thing we got to look for. And what are we always looking for in variation problems? K. Constant K. So as I look at this, I see that x is increasing, y is decreasing. So possible what? What type of variation is possible here? It's possible inverse, right? Because this one's getting bigger, y is getting smaller. So let's find out. I'm going to put possible inverse. It's a possible inverse variation, okay? Horrible spelling, but you get it. Possible. Possible. Oh, c'est un inverso posible. All right, so here's how we're going to do that. What's 2 times 15? 30. What's 4 times 7.5? 30. What is 10 times 3? 30. What's 15 times 2? 30. Guess what we just found? Constant K. Is that relationship, the product between the two, constant? Yes. So do we have inverse variation? Yes. Okay, that's why I said possible at first. I found constant K. I see that constant K is constant. Therefore, it's not possible anymore. It is inverse, and I'm going to write them as such. So y is equal to K. And because it's inverse, where does x go? Top or bottom? Bottom. Inverse. Oops. Why am I going to write a W? It goes on the bottom. Boom. And if we already know what constant K is, what is it?
30.
Guess where we're going to throw it? Yeah, in for K. So y is equal to 30 over x. Bam. Math.
So wait, where does the W?
No, there was no W. I don't know why I was writing it.
Oh,
I know, that's why I said my bad. I was writing a W. Don't even know where that came from.
so there's no W.
No W's. Maybe later. Definitely later. But not right now. I apologize. You're confused?
Dude, I don't know where the W was from.
There's no W's. There are no W's.
So how did the X get on
I was putting a W down here for X
the bottom? Oh, okay.
as an accident. I said, I don't know why I'm writing W. It's supposed to be X.
Oh, okay.
No! Los links! There was no W. The relationship is between X and Y, isn't it?
So then,
Go ahead. Finish that thought, please.
if it's like Z equals KX, Y over W.
Oh, those were examples. Those were examples. Like, I see what you're saying. You're talking about over here, in this spot. These are just examples. In this case, Z, whatever that was, maybe zebras. That's the only one I remember from my alphabet songs. Maybe the number of zebras very directly with the xylophones and the yaks. Okay, so these were just examples of what varies with what. Okay, this does not make anything law. These are just examples. Make sense? Over this one, we actually got to it. The variables that we're working with happen to be x and y. X and y. And we want to know if x and y vary either directly, inversely, or neither. Right? So we said, oh, there's a possible inverse relationship because x is getting bigger while y is getting smaller. Right? Are we catching this? Thumbs up, thumbs down, sideways for now. Okay, so let me clear this real quick. When we got to here, now this is like a whole new problem. And I just want to know if x and y, these variables up here, have any one of these three relationships. They're either very directly, jointly.
No, I understand that.
Okay, so we're good there?
It's just, I don't know the motor function of it, because you added the W.
Oh, I see what you're saying. We'll talk about that in a little bit. I know you're waiting for it, huh? Don't be so anxious. We'll talk about it right now, I promise. But right now what we're doing is saying, you know what? I've got this data, and I just want to know if they have a relationship between them. Okay? And what we did was we found that, hey, you know what? There was a possible inverse. We found that the constant between them was a 30. So that means that y varies inversely to x. So here's the supposed, as you could say, mother function. But I happen to find that x was 30. So 30 is the constant k. That means that y is equal to 30 over x. Okay? And that's it. Okay? This is a really cool function. We'll talk about that in a little bit, okay? Now, let's take a look at the next one, okay? So, new example. I've got a new set of data. I want to know if there's a direct variation, inverse variation, or if there's neither. Okay, so is there a direct? Now, please don't get confused if I say direct or I say jointly. They're pretty much the same thing. They are the same thing, okay? We're talking about the same thing.
Mr. Munoz, did you see Damien at all today? It's his birthday.
Yeah, he didn't come.
How do you know?
I have him first hour. I know. I was never allowed to stay home for my IB day.
He's 18, he's grown.
Also, now he can call the shots. If I'm pro, first act of business, no school.
He's a kid start.
Poor choice to begin with. We have to find his home with the bell. 18, you say? Anybody still do that? Anybody get that done still? Wacky with the belt? Man, I would run.
I just got beat. She said I just got
Back to here. I see that I've got two variables. I want to know their relationship. I want to know if one varies directly or inversely or neither. I see that x is increasing while y is decreasing. So this is a possible inverse relationship, right? So I'm going to say possible inverse. I'm going to say inverse. If I could spell, that's a horrible, but anyways, is it an inverse? Then I find the products between the two. Top one happens to be 20, what is that? 32, 30, 45, 25? Something not nice? What is this? 1.5 of that. That's like decimals in there, isn't it?
22.5.
The last one's 2.5?
22.
Oh. Yeah, so does that have a relationship there, constant K? There's no constant K here, so I'm going to say, what type of association? Neither. I was telling that to someone first hour, they're like, they don't believe me. I said, don't say neither, it's neither. What? There's an E in front of there. So I started making up rules and stuff.
So it's neither?
Is it?
You know what? I don't even know. I've heard neither, I've heard neither.
Yeah, no, I was asking.
Night.
Oh yes, it is neither. Neither of them. Either one.
I don't get how people are like Prescott.
It's a button.
Like Prescott, Prescott.
I'm not gonna argue Prescott, tomato, tomato, neither, neither. But I will argue about this inverse relationship, you know what I'm saying? Alright, how about this one? Go, 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 go. X is increasing, Y is increasing. Possible direct variation here. Because one's getting bigger, the other one's doing the same thing. Is there a relationship?
You still have to do the
Yeah.
product?
Yeah. Constant K, remember? Wakey, wakey. You alright? Kind of, sort of. That's a nice sweater. Oh, I love allergies. Insert sarcasm here. No, 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 no. What'd you guys come up with? Possible direct, is it or is it not? It's not. It's neither. It is neither. All right, cool. I do want to pose a question though. Let's go back to this one. Okay. And let's say that maybe this was a 3.1. What is that? No, let's go 3.2, 3.3. No, let's go 3. Yeah. Nah, let's leave the 1. So let's say that was a 3.1. What's my output? It's 31? Okay, so I have this output here. And I'm asking the same questions. Hey, what type of relationship is there? Does this have a direct, an inverse, or neither? And you would say, okay. You don't want to say neither. You don't want to say neither. What this is doing right now, it's starting to build some of those skills that you're going to need for statistics later on. Okay? And let me let you know a little secret. Math outside of this classroom, in the real world, he's not nice. It's not nice. Okay? People in carpentry, anybody here, whenever you cut a board, is it ever really exactly 12 inches or so forth, so forth? No. Nothing is ever exact. You don't be out there, oh, go get me a board that's, exactly 12 foot. No, you wing it, right? And even then, it's probably a little crooked, got a little angle to it. Math is not nice, okay? When you need a certain amount of cement, Shauna, and you're trying to fill it up, doesn't mean that you're going to get the exact amount all the time. So in math, when we're looking at data, it's not always going to be perfect. But if you can see it, look at the data, it happens to be 30 most of the time, doesn't it? So don't be like, oh, one number is off. They all seem to be gathering around 30. So that would be your constant K. Because what you're doing is you're building a model. You're building a model that's going to help you make predictions about how much do I need. Okay? Even when you go to the butcher, how many people, it's very rare that you say, oh, let me get a pound of chorizo or something. Or let me get 2 pounds of ham. And it's almost never exact, is it? Okay? But it's, and they're like, is that good? Should I take out a little bit more, put in a little more? But what you're trying to build is a model that will help you make predictions. Okay? And that's all that we ever really care about is how much. About how much. Right? So, Once you get into the more exact sciences, when you're doing like microbiology, then yeah, that matters. But when we're working right now, we're trying to make models that can help us predict. Okay?
So what would be this?
That would still be the same thing. It would not change what we had before. All the numbers that we had before would still be the same. Even if this was like a 33, I would still be pretty comfortable saying, it's about 30. Constant K is about 30. That makes sense? All right, cool. Moving on. Determining an inverse variation. Let's determine an inverse variation. All right, so suppose, make this supposition, that x and y vary inversely.
Wait, determining what? Inverse variation?
Inverse variation. Now, let's actually do some stuff, okay? Very nice. So, determining inverse variation. You guys ready? No, but bring it on. So, suppose that x and y are inverses of each other. Can you already see the model that we're going to use? What's it going to look like? Y equals k over x. All right. So there's my relationship. Now they said x happens to be 4, y happens to be 12. What is the model of the function? Well, it's bare bones, right? But we want to find the model when x is 4 and y is 12. So I'm going to plug those in. Y is 12, x is 4, and I'm going to solve for constant k this time. So solving for constant k, look at that. I'm multiplying x and y, just like we did before. So that means that constant k happens to be 48. So if they're asking me for the function that models this relationship, then it should read, any takers? I just found constant k. You guys should be watching, not writing down. See, now we got these what's. Let's try this again. So, Delilah, you gave us this. Fantastic. Or who was it? Somebody. Y equals k over x. They gave me some specific values in there so that I can find the relationship. So I can find that constant k. They're saying when x is 4, y is 12. So 12, I've got k is equal to 4. And I'm solving. All I'm doing is trying to find that constant k right now. I find that constant k is 48. Now the question is, what function models this behavior, or this relationship, or this variation? Constant k, 48. How do I write the model? Thank you, though. Y equals 48 over x.
Plug it in.
Yes! Math. That's it. Just a plug and chug. So there's our model. I've got a question for you guys. How did you know it had to be y equals k over x? Just because people are used to that, right? But what if you went and said, you know what, they're related inversely? That means that x is equal to k over y. That's also an inverse relationship, isn't it? Isn't it, Subia? Yeah. Now you confuse me, Mr. Munoz. Why did you do that? Because I want to make a point. If you're consistent about your work, you're going to end up with the same thing. So let's say that for some reason you don't always go y equals like the rest of the world does, and you happen to go with x equals, you'll be fine. Because you made this model and you're going to make it work for you. Okay? I'm not saying it's wrong. I'm saying that's absolutely fine. It's weird, but hey, no one ever made new math not doing weird things, right? All right, now here's the next question. What does the graph of this function look like? Do it, guys. Go for it. Y equals 48 over x.
Wait, what are we doing? Graph?
Yeah, it says, what does the graph of this function look like? I don't know.
That's a good question.
You know what? Here's what I want you guys to do. Stop. Because Subia asked earlier, I'm going to go ahead and tell you what the parent function looks like. The mother function, okay? The mother function is actually y equals 1 over x. That is the mother function. So throw that into your calculator. I want you to see what that looks like.
That's weird.
It is, isn't it?
Wait, how do you? Wait, how do you?
Anybody need help doing this on the 84? All right, so let me get to the 84. So click this Y button up here, Y equals. And just type 1 divided by x.
That's what I put.
Now do this. Click the zoom button in the middle, and then push number 6 for standard. And you should get a graph that looks like this.
Wait, zoom in what? Standard?
Zoom in 6, yeah. Everybody get something that looks like this? That's pretty cool, huh? Graph just got real. Okay? This graph is asymptotic. It's asymptotic. It has 2 asymptotes. Anybody know what an asymptote is? No? Not zeros. Zeros is where it actually crosses through the x-axis. But if you take a look at this, I'm going to go to the other one because it just looks nicer. It doesn't, you can see the gap there. But you see how it does, it gets close to the x-axis, but it doesn't touch it? That's asymptotic. Imagine in your mind's eye, because only there can you see it, that this line is getting closer and closer and closer and closer and closer, closer, closer still to the x-axis. But it will never, ever touch it. It will get infinitesimally small as it approaches the x-axis, but it will never, ever touch it.
How is that?
That is kind of crazy, right? And I think I've shown you guys my paper example, right? Okay, so if I have this pass here, I've got a full pass, correct? So think about, this is what's happening. It's exponentially getting smaller. So if I cut this in half, I've got half of it, right? See the big jump in the line? If I cut it in half, now I've got a quarter of it. And if I cut that in half, I've got an eighth. And then if I cut it again, I've got a 16th. And then I've got a 32nd. And then I've got a 64th. And then I got a 128th. But you see what I'm doing here? I'm cutting halves away, and I'm cutting halves away. Now physically, I can only do this for so long, right? But in your mind's eye, how long can I do that realistically? I mean, in my mind, how long can I cut this piece of paper for? As long as I want. And that's what's happening here in this theoretical graph. That it's getting smaller, smaller. So that distance is getting half as small, half as small, half as small, half as small, half as small. In this case, whatever x is by, but it's getting smaller, 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 but never, ever, ever touches the x-axis. And on the same note, guess what? It never touches the y-axis either. So it gets closer, 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 never touches it. Down here it gets closer, 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 but it never touches it. Unless, well, that's going to, yeah, the shape will be constant. It'll stay that way. It'll look like that. But how could I get it? How could I force it to touch one of those 2 lines? Okay, I've got these 2 graphs, right? I can't even mimic that. That's kind of
H and K.
H and K. If I shift the whole thing, I kind of force it, don't I? So you could do that, and guess what? We will. We will. But here's the beauty. Here's the beauty, Subia. You've seen it. You know what it looks like. You already know what A, H, and K do. What does A do? It gives it more slopiness. In this case, slopiness will be defined very differently. But then there's H, which will move it up, down. No, I lie. Left, right. And then there's K that will move it up, down. but it behaves exactly the same as all the other functions. It does not break the rules. So in this case, what we do, what's important here is the 0.00, because that's what changes up down. That's where those asymptotes are, okay? Thanks for the discussion. Let's move on. We went way beyond what we needed to. All right, so now here's the other example. We have this model, which is y is equal to 48 over x. The next question is, well, what's y when x is 10? Well, what do I do with that 10? Throw it in for x, and then find out what it is. And what's the value of y? There you go. 4.8. And we're done.
Didn't we do this before?
Yeah, with direct variation.
10 for, oh, 10.
Then why
Is
is
that
it
different?
the same?
This is inverse. So we did direct variation, that joint variation, but now we're adding inverse as well. Because guess what? We don't always, our relationships in real life don't always just have a relationship. There's a couple different things going on. And if some go up, some might go down. Okay? Yeah. Questions? Don't do it. Alright, can I change the slide?
Wait. How you
That was our model.
Oh.
That's what we got from the last couple of slides.
Oh, is this still there?
It's still the same one. This is just part C of the question. Okay? Can we move on? Shauna? Shauna? Alright, do we need to do another one? You guys good? Show me those thumbs up, thumbs down, sideways. See those thumbs, let me see those thumbs, let me see those thumbs. Are you praying back there? I'm meditating. I'm looking at the notes on my shirt. Alright, cool. So then we'll move on. Using combined variation. So here's what I was talking about. Sometimes it's not always going to be just direct or just inverse. Letters are a little small, so I'm going to have to read this to you. I'll read it once and then we'll start with it, okay? It says, the number of bags of grass seed, N, needed to reseed a yard varies directly with the area to be seeded and inversely with the weight of W of a bag of seed. If it takes 2 3-pound bags to seed an area of 3,600 feet squared, how many 3-pound bags will it seed to get 9,000 feet squared? So let's start this again. They're telling us that the number of bags, which we're calling N, it varies directly with the area, which we're calling A, and inversely with the weight of a bag. So there's my little skeleton. I'm missing something though. What am I missing? I'm missing K. Does it go on top or bottom? When?
Always.
Always. So I'm going to throw K up here. So there's my model. I need to put some stuff in so I can get constant K. So let's see here. It starts over here with the if. If it takes 2 3-pound bags, that's a lot of information right there. Isn't it? Because what does the 2 mean? It's 2 bags. And if you take a look at it, N is the number of bags. And what does 3 pound tell us? The weight of the bag, which happens to be W. So it's a 3-pound bag. So I've got 2 3-pound bags. And I know that those 2 3-pound bags will do 3,600 feet squared. So I've got this thing going on. Multiply.
Silence our classes for the 10. That's weird.
That's weird. I'm going to find what K is. So I'm multiplying both sides by 3. There's 1. So that gives me, I don't like that. That gives me 6 is 3,600 K. And then I'm going to divide by 3,600. That's gone. That means that K is equal to 1 over 600. Because 6 goes into 36 6 times. And then I just add the 2 zeros. Math. All right, so what's my model? And it's not YOLO.
What's your bottle?
The model to this. it should read, I'll use another color. It should start with n equals something. What that? What that? What that motto? A. I can throw A up there. Well, we know K. K is this fraction 1 over 600, and then the weight, well, we don't know, it's W, right? So, there's my model. It's kind of gross, but it'll work. Does everyone see where everything went? Here, I'll do one better. I'll do this. Okay? You should be watching me for now, though, so that you don't lose anything. So I've got this. I plugged everything in. Now, the last question says, how many 3-pound bags will seed 9,000 feet squared? So I'm trying to find n, and I want to seed 9,000 feet of land. I already got constant K. Now, what's the weight of the bags I'm using? They're 3-pound bags. So I've got this going on. Well, it's not bad. Let's worry about the top first. What is 9,000 divided by 600? Thank you for picking up that calculator. Thank you. Now I'm going to divide that by 3. Yep, so guess how many bags I need? I need 5 bags to do that 9,000 foot square field. Now I want to point something out. Remember I said that you always throw K on top? In this case, K turned out to be a fraction, right? It turned out to be a fraction. So I'm just going to write this. What color have I used? Green. You could have done this as well. A over the W, because K was a fraction, you could still write it as such, like that. But do you see how I still have the 1 on top and the 600 on the bottom now? I know. That's why I did it this way. It makes more sense to people for some reason. Personally, I think it's kind of grody, but if it helps you, there's nothing wrong with that. There's nothing wrong with that. I actually think this is a higher order thinking skill than the one up there. But that's my opinion, and I am no one. But either way, you'll be fine. You good? Any questions on anything I've said so far? All right, let's gauge your knowledge. Fist of 5. How we got this? 5 means I can teach this to somebody. 4 is I'm good to go. 1's like, or 0's like I'm lost. Where am I again? All right, cool. I know. I just want to gauge this real quick. I know you guys will be more honest. On my exit ticket, please go online and do that as you start your